Okay, so now we want to move to the next subtopic, which is absolute extrema of multivariable. Okay, so by finding a local extrema is not enough. Okay, for some problem. Okay, so it's more useful is to find the extremum value. Okay, on any given region. Okay, so for this subtopic we have two problem, which is we have the theorem 7 here. Okay, the absolute extrema is the value on the any given region. Okay, and then we will look at the next theorem, which is the case where the region is may not be closed or bounded. Okay, it can be up to infinity. Alright, so now let's look at the first case. Okay, so absolute extrema is the value on the any given region. From this theorem, okay, it said that if a function is continuous on a region that is closed and bounded, okay, so this is closed and bounded, then it has both absolute maximum and absolute minimum in the region. Okay, so we have two value, which is maximum and minimum. Further, the absolute extrema must occur either at the critical point in the region or on the boundary of the region. So we need to test all the value. Okay. Okay. So how we want to solve for this particular problem, where the region is closed and bounded? Okay. So let's say we are given the fxy. Okay, let's say the z is equal to fxy, and then we need to find the partial fx and the partial fy. Okay, step 2. Okay, we need to let both fx and fy equal to 0 and solve simultaneously to find the critical points. And then step 3, we need to compute the values of the fxy, okay, at the critical point that we already obtained in step 2. Okay, and at the boundary of the region. Okay, boundary of the region will be given. Okay, alright. Step 4, we need to compare all the values. Okay, the critical point and also the point at the boundary of the region. Okay, the highest value. Okay, we need to calculate for the fxy. So we substitute the value. Okay, the highest value for the fxy, we consider as the absolute maximum. And if the lowest value of xy is the absolute minimum. Okay, so for the closed and bounded region here, we no need to derive the second derivative test. We don't have to use the second derivative test. Okay, so we will look at the example. Okay, so in this example 1, okay, we need to find the absolute extremum of fxy equal to x squared minus y squared on the region. Okay, so if we are given this region, for x is from minus 1 to 1 and y is minus 1 to 1. So we know that this type of question is referring to closed and bounded region, because we are given the r is minus 1 to 1 and minus y is minus 1 to 1. Okay, so it is closed and bounded. So we need to use the these steps. Okay, all right.